Hi all, welcome to our final lecture, number 12 of GG497 Geological Visualization. This will be a relatively short one because what I want to do is go through what our alternative assessment will be. Obviously we can't have exams because of the COVID situation, so what we're going to do instead of having a formal exam is you'll be given a worksheet, like a list of questions, which I'll make available on Student Central, and those questions will be based on a real geological map which you'll be able to look at on your own computer or other device and answer some questions. So we'll have a real geological map. There'll be a structural contour exercise similar to those ones that we've had in a couple of the labs so far. But basically what you'll need to be able to do in order to make a success of this assignment is recognize different geological features, interpret what structures would look like in cross-section from how they appear on a map, simple calculations to do with scales or geometry of features on the map or something to do with the stratigraphic column, be able to draw cross sections and be able to put everything together to write a feasible geological history. So this is a map of Haverfordwest. This is the map you'll be doing in lab number 12, and you can expect a map that looks a bit like this. It won't be Haverfordwest, I guarantee you that, but it'll be a similar level of geological complexity. Okay, so we've gotten to the point now where we have seen all of the different geological features, like folds and faults and dipping rocks and unconformities and things like that. And what we've got is a map that's like Haverfordwest, which contains all of these features. So why don't we go through and recognize what geological features we might be able to see. If we just take a minute to soak up that map, what sort of things can we see? Well, the thing that really strikes me is that the outcrops are forming these strips. That when you look at them, they have these complex dips, some of which are pointing away from each other and some of which are pointing towards each other, either side of one of these strip-like repetitions. And that suggests to me that we've got a series of folds. We've got some antiforms, we've got some synforms, we've got some open folds, and we've got some tight folds. And if I were to mark on the fold axes for the major ones that I can see running through the area, I think they run something a bit like this. I can also see that there's this unconformity between our younger Devonian and Carboniferous rocks and our older Ordovician and Silurian rocks. If we get rid of those fold axes just for a minute, you can follow some of the contacts in the Silurian rocks, and as we follow them round, they get stopped at the unconformity with the Carboniferous rocks. I think there's more over here. If we follow this stratigraphic contact, it just stops at this unconformity. So we've got fold axes, we've got unconformities, we've got cross-cutting intrusions. See this big capital D here, we have some dolerite bodies that have been intruded or faulted even into contact with the younger Carboniferous and Devonian rocks. I can also see that there are these little faults. Some get bigger, but I can see that they have had displacement along them. If we follow this bed of limestone, for example, we can see that it's been offset by a few tens, maybe 100 or so meters on the other side of the fault. So we've got a series of faults. And looking at those folds in more detail, I can see that in the southwest of the area we've got these divergent dips, which indicates that we've got an antiform, where the exposures close towards the southeast, indicating a plunge direction in that direction. Whereas the next fold, as we go further up, that's cored by this carboniferous coal measure material, those dips are converging, so that indicates that we've got a synform, but those outcrops are opening as we head to the southeast, so that too is the direction of plunge. So that's how I might interpret the geometry of some of these folded structures. Then if I were to interpret the sense of movement of this fault, I think if I was stood on that map looking across the fault, I would see that the rocks on the other side of the fault had been shifted to the right, they've been moved to the right, so their sense of movement would be dextral. And then if I were to think about this in 3 dimensions, well, if these rocks are dipping 42 degrees to the south, and the eastern side, and these faults are dextral, with the eastern side of the fault looking like it's gone to the right if you were stood on the western side looking across, I can ask myself which side has been down thrown, and if the rocks dip towards the southwest 42 degrees, then the western side of this fault must have been pushed downwards in order to make the outcrops of those limestone beds appear further south. Okay, so we can interpret the structures, we can interpret folds and faults. Then we can be expected to ask or to answer some simple calculation questions. So for example, a calculation that might be based on the stratigraphic column. What is the thickness of the main limestone? Well, we can see the main limestone is here, and if we measure that on our stratigraphic column, we see that the thickness is 4.5 centimeters, which when we multiply it by the scale factor, we can work out that the main limestone has a true thickness of 450 meters. Very simple calculation. To something slightly more complex, like if we were to be asked what's the average rate of deposition during the Carboniferous, which is from 359 to 299 million years in millimeters per year in our area, well, we can see that the Carboniferous rocks, they have a length of 18 centimeters on our stratigraphic column, which when we multiply it by our scale factor of the stratigraphic column that says that 1 centimeter is 100 meters, that 18 centimeters becomes 1800 meters, which is the same as 1.8 million millimeters. So that 1.8 million millimeters was deposited in 60 million years, which is achieved if the average sedimentation rate is 0.03 millimeters per year. Then there'll be simple calculations involving structural contours, where you'll have to draw some structural contours on a feature and then calculate what the angle of dip is and the dip direction and strike and so on. Then there'll be a cross-section that's required, that you are required to draw. You'll be given the points, so you won't have to pick your own. You'll be given where the section line will be. And my hint for when you're drawing this section, you have as much time as you need to do this, is to make a little bit of a summary or keep in mind what the structure of the area is in general. If it helps you to draw a little summary map which crystallizes your ideas, that's fine, you won't need to, but it would help you to have an idea of what's going on before you tackle this head on. So you might come up with some cross section. If for Haverfordwest that might look a little bit like this. And marks will be awarded for the surface locations of the contacts where they'd be on the ground surface. How those contacts would continue in the subsurface, so what they look like on the cross section itself. A sensible projection above the ground. Useful labels, a key which helps me understand what you're trying to show, and a scale or scales. So if you can include all of those things on your cross section, then I have no choice but to give you full marks. And then lastly, once you've done all of these questions, got them together, you'll be asked to come up with a geological history for the area, and the marks will be awarded for this if you can be able to place in the correct order and explain the main phases of things like folding, of erosion, depositional environments, of faulting, and any magmatic or intrusive activity. Okay, so what I'd suggest you do now is have a little look at the introduction movie to the Haverfordwest lab. Try it yourself, and if it's completely opaque to you, then let's make an appointment to chat on Microsoft Teams or over email something before you start the coursework properly. Okay, thanks guys. I'll chat to you when I chat to you.